Hello everybody from Tennessee. Let's get started. And so here we have my final report about my project. And let's go. So here we have my project, that is water usage in a brewery industry. Consumption rate of water. Alright. Here we have that beer is the one of the most consumed drinks in the world. So if we catch the 10 largest brewer groups, they are able to produce 50% of the world production. So it's like more than 100 million of hectoliters per year. So it's a lot of things, and we need to pay attention in this project. So as the production, the water represents a fundamental natural resource for the operation and the productive performance. And the process requires a high consumption of non-renewable sources such as water and energy. So it spends a lot of water and energy in this production. And the current scenario requires that breweries need to find some strategy that will reduce the environmental impact production. Okay? So the world scenario says that you need to use the less resources as possible. Okay, so the reduction in the water consumption can be achieved through process optimization. Okay, and that's what we are doing here in this project. Yes. So here in Brazil, the national production is very high. So the present work has the objective of reporting a part of a water consumption reduction project of a brewery that is located in São Paulo, here in Brazil, in Jacareí City, Vale do Paraíba. Okay, it's a city like Vale do Paraíba is near from beaches. Like, it's not a beach, but it's near there. So that's where the company, this unit of the company is. The company itself already does a monitoring of this water index, but they really intend to reduce it because they spend really high levels of water. Yes. So here we have the problem definition. Okay, the process at all is very big. The brewery is, there are many areas we can work with, but that's how we choose our area. The process is very big, how I said, and it was decided to choose a punctual problem to present here. Okay, so the punctual problem was decided by the Pareto chart. Okay, here we have it. These are some areas. We got some data from them, and we could construct this Pareto chart. Okay, these data are from 2017, last year. Okay, and we could find these values here, the percent that they spent over here, and they come here. So the decision was taken following the results of the Pareto chart, how I said, and we choose packaging 542, how we choose it. Okay, but packaging 542 spend more than 10% of the levels of water of the unit at all, okay? So exactly the value here is 13.9. So it means that's a significant consumption, more than 10%. So we decided to look at it with more attention. And then a tour was made there by the area to check what was really happening there and how everything works there. And then this time was when we saw that there was a huge leakage in the skid bomb there in packaging 542 in the filler. That is a equipment that they use in this area, okay? So the next step was to make the construction of the diagram of this area, and then we could find that here we have the filler. Here starts the production, the black line is the production, and the blue one's the waterway. So here when the production passed through the filler, we have a problem with the skid bomb. The skid bomb needs to work with a cool temperature. So that's why the water is useful there, to get the bomb in cool temperatures, okay? So by an interview with the operator of the area, we could know that the skid bomb of the filler is not working very well, because the exit water was supposed to be sent to a recovered water tank that they could use it again, okay? But it's being lost to the drain. So we are not getting this water back. And there is a leakage at the exit of the bomb because of this. So it's not working very well, okay? And for this problem, we don't have a periodic maintenance plan for this equipment. So it's like they don't give much attention for this. They think it's normal because they don't follow a plan because it don't exist, okay? So the impact here by the workflow of the bomb, it can operate at the maximum flow rate of 60 liters per hour, okay? This is the maximum as it operates, and we consider this maximum, okay? And it works almost 24 hours per day. So it's a very huge work, and in a month we would have this value, 43 million and 200 liters per month being wasted, okay? So it's a huge value, and if they don't spend this, it obviously we're going to impact in their water index, okay? So it's a huge problem. They don't really give a care for this, so we need to check, we need to correct, and it's going to be very important, okay? So, areas of potential improvement there. Here there's some actions that we needed to do to correct this, or at least to reduce this impact, okay? So why is it happening? We need to check the water exit pipe. What is happening, okay? We need to make a report, write, and we need to really check this. Have the water really gone to the recovered water tank? If yes, what's happening? Why is not going anymore? Okay? How much will the repair cost? We need to make a budget of bombs, okay? We can make a budget of bombs that work in a closed circuit, okay? So they will expend almost always the same quantity of water, and analyze if the exchange is worth. And we can also make a budget of bombs that work with another fluid. So what have I already done here? I consulted 3 suppliers, but I just consulted the suppliers for the closed circuit, okay? I didn't find bombs working with another fluids because they are really expensive. So I decided to go through this way, okay? We have 3 suppliers here. This is the cost of the bomb. Here it is in reais. So 1 real it's almost $3.96, okay? So we presented it to the manager of the industry, but there is a point that needs to be considered here, because there's something that must be considered, okay? There is another packaging stations there in the brewery, okay? Packaging 542 is only one of them, and we need to analyze the macro process and then make another analysis to each one of the stations, okay? And we are also having problems in the other stations with this bomb. So we cannot consider only this price. We need to make the project for the other stations too and analyze if we are going to need more bombs. And as the operator already said to me, there is at least more 3 bombs of this that needed to be checked. So it's gonna be like at least $25,000, sorry. Okay, so it's an expressive value here, and we need to check if the manager is going to accept. Okay, how can it be fixed? We need to analyze and compare this budget as soon as possible and decide if it's worth it to buy new bombs or correct punctual pipe problem, okay? It's a maintenance problem, so the maintenance group need to check it, okay? So, the conclusion here is that the water lost could be used to various purposes, other purposes, like such as cleaning common areas, okay? So we are losing much of water that could be used for other reasons, okay? And if we have even proper treatment for this lost water, it would be even possible to reuse in the production, okay? And in addition, the bomb here can run in a closed circuit, okay? And it would spend a small quantity of water, so it needs to be analyzed, okay? And to conclude it at all, we can see that the project management combined with the environment design and reuse issues, as well as production flow mapping and process study, were essential for this conclusion and the results of the present work, okay? So that's how I mapped my project. Thank you, guys. Let's talk later, okay? Thank you for everything.